All right, so this is Unit 7, Lesson 7, the unit circle. And we got a nice unit circle here with some points on the perimeter. And it's got some questions about some line segments on it. And I have my handy dandy memory aid. If you haven't memorized this yet, we used it in the last section. We're going to be using it on this one as well. I'm going to do a real quick recap of all this stuff as well to help us answer some of these questions as we go along. Okay. Well, I also have a copy of this, so when I flip the page, I don't have to go back and forth all the time to answer the table in the back. Otherwise, we'd lose our mind. All right, so first question is, well, what is given the coordinate plane? This is a circle, and it gives us 1 point. It gives us the point 0, 1, right? So that means that this entire thing. So what does that mean about this point here? It's a circle. That means that this point is 0, negative, or 1, it means that this point is negative 1, 0. It means that this point is 0, negative 1. That means that this point is 1, 0. Well, how do I know that? Well, it's because it's a circle centered at the point of origin. And it means that the radius of this circle is 1. Okay, so what is the length of the radius circle? W. All right, so this is the circle W. The radius of this length of the circle is 1 because it intersects at point 0, 1. Okay, and so the radius is 1. Alright, because it intersects at 0, 1. And it also intersects at no, it doesn't really mark it, but it should. It should mark out one of these, but it doesn't. But it should. But the intent of this is that all of these are the same length and stuff like that. Okay. So what is completing the table? What is the length of line segment? WM. Right. So where's W? Origin is right there. Well, the origin is W. So WM, well, that is the radius. So the length of that would be 1. And then PW, again, from the circumference to the perimeter, that would be 1. All right, but before we go any further, let's examine this a little bit more. So each one of these radii that extend from the origin to the circumference, to the outer diameter of this circle, are the radius. Right? Each one of these are the radius here. So that's a radius. Well, and it's also the hypotenuse of each one of these triangles. Whether it's a 30, 60, 90, or the 45, 45, 90 triangle, it's the hypotenuse of either one of those triangles. I'm gonna not exactly on line with the triangle, but it'll make it pop a little bit more if I color it in. Okay, that's all right. Okay. So now let's do a little bit of math, knowing what we know about, can't even see this one. Alright, now you can. The light on. Okay, there we go, that's a little better. Know what we know about these triangles, these 30, 60, 90 triangles. So let's identify on these. Well, let's do the 45s first. Okay. What do we know about the 45s? Well, the 45s, they don't have a short leg or a long leg. So this is the leg. They just have legs. Right? This is a leg, and that's a leg. Right? That's a leg, and this is a leg, and this is a leg. And they're equal in measure. Okay? So what is that? What is that relationship between the leg and the hypotenuse? Well, if you don't remember, the leg, if I take the leg and I multiply it by the square root of 2 of the hypotenuse, it is, sorry, if I take the leg and I multiply by the square root of 2, I get the length of the hypotenuse. Okay, so these, if I were to solve the length of the hypotenuse, right, this is square root of 2 length times square root of 2. Okay, so there's this. This is the L, the purple L times the square root of 2. Right? For those, let me make that more obvious. Color coded. This is length, purple length times square root of 2. Times square root of 2. Okay, that's purple length times square root of 2. Alright, so these, therefore, would be the hypotenuse, which we know is 1, right, divided by the square root of 2. Right, so L, all of these purple L's, all these purple, the absolute value, right, equals the hypotenuse, or equals the square root of 2, equals the square root, or equals 1 divided by the square root of 2. Right, because if I just rearrange this, right, it would be short leg. This one, it would be the leg equals hypotenuse divided by square root of 2. I just divide square root of 2 by both sides, right? So, and that's mathematically it's like mathematically correct, but it's not really kosher. I guess the wrong word, but it's not really acceptable in mathematics to leave a radical on the bottom, right? So in order to get this in the right mathematical arrangement, we multiply both the top and the bottom by the square root of 2, right? So 1 times the square root of 2 is the square root of 2, and 2, or correction, the square root of 2 times the square root of 2 is just 2, right? So the length of both of these is the square root of 2, okay? So if you were to look at this 45 degree and you were to superimpose it onto like this one, it would be like right here, like this point M. Point M would fall like right here if you were to flip it. If you were to reflect this triangle over the y-axis, right? M prime would be like right here, right? And if you were to reflect it across the x-axis, if you reflect it across the y-axis, it would be right here. So it's in between, like in between the range of 60 and 90 degrees. So I call this the middle distance, because it's the distance from either the x or the y-axis. Okay, it's always going to be square root of 2, right? Wherever the radius, when the radiuses are, whenever the measure of the angle between the axis and the hypotenuse is 45, because that's 45 and that's 45. This distance the x, or the distance between the point, like this point here, between the x value or the y value, for the x and the y value from the origin, is always going to be square root of 2 over 2. Okay? It's the middle range distance. Okay? Now let's look at the 30 and 60, 90 triangles. Okay, here's the 30 triangle, the 30-degree distance. Right? So the opposite length is my short distance, my y value. I'm going with my green, my y value. Okay, my y value, if you remember, my y value is 2 times the short length. It's my short leg. Right? So if I wanted to put this, or if I wanted, or it's not 2 times the short leg, it's 2 times the hypotenuse. Right? So if in this case the hypotenuse is 1, right? So the distance, or in this case it would be my distance from for the x value in this case, or correction, the y value in this case, it would be 1 over 2, right? Because it's opposite over hypotenuse. Because that's going to be 1 over it's the short leg. It's the shortest distance I'm going to be able to get from my x-axis. Okay, so my length for that is 1 over 2. This is my short length. Okay, and then my long length that I'm ever going to get from any axis would be the one that's opposite of my 60-degree angle, like from here to here, for instance, regarding my x-axis. Right, that long length here is going to be square root of 3 times my short length. Right? So if you look at that, that turns out to be my long length. My greatest length is going to be, algebraically, it turns out being square root of 3 over 2. Right? If you just do the math, it ends up being square root of 3 over 2. Okay? So that's where you derive your 3 values for your distance from any one of your axes. Right? For if you look at this one, this is a 60-degree angle, right? So my distance from my y coordinate is square root of 3 over 2, right? For my y value, or for my x value, excuse me, right? And then for my y value, my distance from my x coordinate is 1/2. Right, so your x and your y values are either going to be in your for a 30, 60, 90 triangle are either going to be 1/2 or square root of 3 over 2 for the absolute values. Now they're going to be negative or positive depending upon what quadrant they're in. Okay, so I have a table in the back to show you how to figure that out. If it's a 45-degree angle, they're going to be square root of 2 over 2, negative or positive depending on what quadrant they're in. Okay, so let's see how this all works out. So here is my table here, and it starts with point L. I gotta try my thing not to go out here. All right, so there's my table for my reference drawing, and I have the point pair. This is at point L, point P, point K, R, and M. right? And then my point that I'm trying to figure out, and then the reference axis, so that you don't get confused, okay? All right, so then it's the relative distance, and that's the small, medium, and then large, right? The medium is only for 45-degree angles. The small is for the opposite angle, or is for the line segment opposite your 30-degree angle. And then the large is for the line segment opposite your 60-degree angle. Okay? And this is the standard value. And that's the standard value. Short, long. This is short, long, or medium. Standard value. And this is the quadrant. Right? This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Both are positive. X's are negative. Both are negative. Y's are negative. Okay? So that's how you figure that out. And then after you figure all that stuff out, then you get the resulting coordinate. All right, so let's go through L here, point L. Okay? I'm just going to carry on with purple the rest of the way. Otherwise, this would take all day. All right, so point L, it's a 45, 45, 90 triangle. Right? So the relative distance is going to be medium. Medium. The standard value is going to be square root of 2 over 2. Okay, for both. Okay, the quadrant they're in is in the third quadrant, so they're both going to be negative. They're both going to be negative. So the resulting pair is negative square root of 2 over 2, negative square root of 2 over 2. Right? So the coordinates are going to be negative square root of 2 over 2, comma, negative square root of 2 over 2. Okay? It's that easy. That is the point. That is the point value for this point. Negative square root of 2 over 2, comma, negative square root of 2 over 2. That is that point value. All right? You could also put it in its decimal form if you wanted to. Where'd my calculator go? It's like 0.707 or something. Let's see. Square root of 2 divided by 2. Yeah, 0.707. I like to put it in that form because it's more precise. All right. So point P. Point P. Okay, this is a 30-degree triangle. All right. So I'm going to have two values. So for my X value, I'm referencing the Y axis. This is going to be my long distance. My long value is square root of 3 over 2, which means my short value is going to be 1/2. Okay? And that's relative to the X coordinate. All right? So I skipped a step. Square root of 3 over 2, 1/2. So this is long and short. Okay, so what quadrant it is in? This is in quadrant 4. And in quadrant 4, my x's are positive, my y's are negative. So this is going to be square root of 3 over 2, comma, negative 1/2. All right, so it's going to be square root of 3 over 2, comma, negative 1/2 for the answer. Okay, square root of 3 over 2 is like 0.87 or something like that. Square root of 3 divided by 2. Wait. Square root of 3 divided by 2. Yeah, it's like 0.66 something. Okay. Now point K. Point K is right here. All right, so we know that point K is going to be, what is the X value for point K? Or what is the Y value for point K? The Y value is 0. We can skip right to the bottom and say the Y value is 0 because it sits on the X axis. Okay, so but what is the X value? It's going to be negative because it's on the -1. And then what is the value for that. We kind of already did the math for this one. Okay, so we know that for a 30, 60, 90 degree triangle, this is the short leg, right? The short leg is 1/2 the hypotenuse. The hypotenuse is 1, right? So if this is 1, then the short leg must be 1/2. Right, so this is -1/2, 0. Okay, I can skip all this stuff. Don't need it. Okay, R is up here. Okay, so R, it's a 60 degree, so it's opposite the long leg. Relative distance from my let's see, my y-axis is the short, and relative distance from my x-axis is the long. So it's going to be 1/2 and square root of 3 over 2. Does that make sense? Yep, this is going to be negative, and this will be positive because it's in quadrant 2. Negative, positive, -1/2, square root of 3 over 2. Okay, so this is going to be -1/2, square root of 3 over 2. All right. Now going on to n. Okay, n is going to be x is 0, or correction, y is 0. And then this is a 30, 60, 90 triangle. This is the long leg. Right, so this long leg on n is this is the long distance, right? This is the long distance that we can get. So this is the square root of 3 over 2. And it's in the positive, it's the positive axis. That's all we need to do. So it's square root of 3 over 2, square root of 3 over 2, 0. Okay. M here they're both positive. This is in quadrant 1. It's a 45, 45, 90, so it's they're both medium distances, and it's square root of 2 over 2. Right, so it's going to be square root of 2 over 2, square root of 2 over 2. So it's going to be square root of 2 over 2, square root of 2 over 2. Awesome. All right, and then the last one is H. Where's H? All right, this one's easy. Okay, it's the x coordinate. So it's the y value is 0. It's negative, and it is a 45 degree angle, so it's square root of 2 over 2. Okay, so that's it, right? Knowing your 60 degree, 30, 60 degree triangles, right? So each one of these, right, if you see the pattern, it would go around in a certain pattern here, right? And it would be your it'd be 1/2 for your x. Let's just look at your x value. Okay, your x value, this is the longest you're going to get for x, so it's square root of 3 over 2, and square root of 2 over 2, then 1/2, and then again -1/2, negative square root of 2 over 2, negative square root of 3 over 2. Right, see how the pattern kind of goes just for your x value? And then it would be negative square root of 3 over 2, negative square root of 2 over 2, -1/2. Right, x value again, now it's going to be positive 1/2. Right, and then the next one is going to be square root of 2 over 2. Right, and then this one will be square root of 3 over 2, because it's your longest. Right now I got all my x's. Now if I do all my y's, I'm just looking at my y values. Okay, the distance from the x-axis, right, from here to 0, this is my shortest, 1/2. And it's positive. These are all going to be positive up here, right? Square root of 2 over 2. Longest, square root of 3 over 2. Square root of 3 over 2. Square root of 2 over 2. 1/2. Right? Shortest distance for this point that I didn't draw. Okay. Right now everything on this side is going to be negative, right? Because they're all below the x-axis, right? It's the shortest distance from my x-axis. Negative 1/2. Negative square root of 2 over 2. Negative square root of 3 over 2. The longest distance from my x-axis. Okay. And I got my, again, now it's still negative. Negative square root of 3 over 2. This is negative square root of 2 over 2. The square root of 2's over 2's are always together because they're part of the 45-45-90 triangle. Okay, and this is negative 1/2. Right? That's your unit circle. Know the pattern, right? Short, medium, long. If you know where those are derived from, these ones here, they flip and flop signs based upon the quadrant they're in. You're home free. Okay? It's easy. Hope you get it. If you don't, please come and talk to me. And I don't know if you saw all this stuff down here, but I hope you did. Anyway, I wasn't really paying attention to the camera that time. But anyway, hope you understand all that stuff. Hope you guys have a great night. Bye-bye.